Index law number 3 and zero indices. So index law number 3, we can remember it as stacking it up. Okay. So again, index notation is just a lazy way to express multiple multiplication of the same number. Then what if we have multiple index notations multiplied together, like this one? Can we make it shorter too? When 5 to the power 2, so 5 squared multiplied by 5 squared, multiply 5 squared, and multiply 5 squared, can we make this expression shorter? Well, if we see 5 squared as an entity, and let's make it a y, so we use the capital letter Y to represent 5 squared, then the entire expression will become 4 of the y multiplied together. And according to the basic definition of index notation, that can be written as y to the power 4. When we put the 5 squared back into this expression, which is y to the power 4, then we basically get 5 squared bracket to the power 4 will equal to 5 squared multiplied 4 times. That's just it, right? So here we figured out 4 of the 5 squared multiplied together can be written in index notation as well. We just need a bracket and to the power 4. But what does this equal to? Well, according to the first index law, we can take 5 as the base and adding all the indices together. So we have 4 of the 2 adding together. And you know from very early on, 4 of the 2 adding together can be written as multiplication, that is 4 of the 2 multiplied together. So, it's 4 of the 2 adding together should equal to 4 times 2. So that literally just means 4 of the 2 adding together. Remember, multiplication is simply a shorthand for addition. Okay? So what is 2 times 4 then? That's 5 to the power of 8. So after this series of derivation, then we basically can conclude if a base is raised to a power, then bracket, then the whole index notation is raised to another power. That simply means we can write it as this base to the indices multiplied together. So we have the third index law. So we're stacking the index notations further together. So a to the power of n to the power of m can be written as a to the power of n times m. Now let's see how do we apply it. How do we simplify x to the power of 5 bracket to the power of 4? So we know that we can retain x as the base and multiply the indices as they are stacked together. Okay? So that will become x to the power of 5 times 4, which is 20. Okay? And b, we retain y as the base and multiply the indices. The power only applies to the bracket term, which is y to the power of 5. Okay? You can see that here the number 3 is not in the bracket, so this square does not affect everything that's outside the bracket. Okay? So here 3 times y to the power of 5 bracket squared then equals to 3 times y to the power of 5 times 2. The indexes, when you stacking up them together, they are multiplied together. That equals to 3y to the power of 10. Now, we have 3 index laws now. Can we combine them together to simplify the index notations? Okay? For example, for A, the order of the operation is always bracket first, then multiplication or division, right? For that reason, we should always apply index law 3 to remove the brackets first, and then use law number 1 and 2 to add or subtract the indices of the same base together. Okay? So here, I will show you the third case later. Let's deal with the first two first. Okay? So x squared to the power of 3 times x cubed to the power of 5. Then that will expand to x to the power of 2 times 3, and here x to the power of 3 times 5. That is basically x to the power of 6 times x to the power of 15. Then applying index law number 1, we have x to the power of 21. Yeah. For B we have m cubed to the power of 4 divided by m to the power of 7. We do the same thing. We retain m as a base. So on the numerator, we have m to the power of 3 times 4. That add up, that multiplied to m to the power of 12, right? From here, we apply index law number 2 to subtract the indices, and therefore we have m to the power of 5. Then before we address the third case, we have to bring up the question of the 0. 0 is always the enigma in math. A lot of laws apply to everything but 0. So 0 sometimes have its own case. But here, we can actually include 0 in our discussion. For example, according to index law number 1, if a to the power of m, we can view it as a to the power of m plus 0, because m plus 0 is m, right? So 0 can be added to any random number. And according to law number 1, that can be written as a to the power of m multiplied by a to the power of 0. And that should equal to a to the power of m. So a number, so an index notation, a to the power of m multiplied by another number, that's a to the power of 0, equals to itself. In all our numbers, there's only one special number that fits this definition, and that is 1. Because any number, when you multiply by another number equals to itself, then that number that you multiply by should equal to 1. And therefore, from there, we can conclude that a to the power of 0 should equal to 1. With that in mind, let's simplify this index notation. So number and number can be multiplied and divided by themselves, and then the rest of the letters, because they are the same base, we can put them together, applying different laws to simplify the notation. Okay? So first, that becomes 3 times 4. I'm rearranging the order of multiplication, which is perfectly okay. So we can put x together and numbers together. So from x to the power of 2 multiplied by x to the power of 3 would then equal to x to the power of 5, right? And then we simplify it by using law 1 and 2. That becomes x to the power of 2 plus 3, take away 5. 2 plus 3 is 5. So 5 take away 5 is 0. So this whole term with x becomes x to the power of 0, which is 1. Okay? So then this entire expression can be simplified to just 12 divided by 6, which is 2.